So Kevin Kelly is not only one of the foremost innovators and writers about technology, but his personal story is an equally interesting one. He rode his bike across America and back, and wrote a haiku and drew a drawing for every day of that journey. He spent 7 years walking across Asia, and he published a beautiful book of his photography from his travels called Asia Grace. I first met Kevin when I was 5 or 6, when my dad took over the role of editor from him at the Whole Earth Review. And Kevin Kelly was the founding executive editor of Wired. He helped design and launch The Well, the famous prototypical virtual community, as well as Hotwired, the first commercial webzine. He is one of the founders of the Long Now Foundation, and he also creates and publishes the website Cool Tools. He's also a regular contributor to the New York Times Magazine, publishing features on digital culture, and one of the last ones was an education issue about homeschooling his son and the role that technology played. His books include Out of Control, Rules for a New Economy, several editions of the Whole Earth catalog, and today he's going to be talking about his latest book, What Technology Wants. So please help me in welcoming Kevin Kelly.
Thank you, Mimi. That was great. It's great to be back here. About 6 years ago, I actually gave a talk thinking about this book in this very same room on the history and the future of the scientific method. And that talk is now 2 pages in this larger book, which is about the long-term trends in technology. And there's lots of things that I feel like I could talk to you about this afternoon, but I think I could talk about the future of media, the future of the internet and the web, and those kinds of things, all of which you probably know a lot more about than I do. And I think I'd rather instead like to step back and talk about what technology means and where its place in the world, where it wants to be in our own minds as we make all this stuff. So every day, you folks are involved in creating new things, and the problem is we don't really have a very good theory about what it is that we're making. And so the current idea about technology is basically it's one thing after another. All right, we produce one thing after another, and there's no kind of larger framework about whether these are good things, whether we want more of it, where it fits into the cosmos, how it relates to nature. And what I'm trying to do is basically make a first draft for a theory of technology. So you can think of it in those terms. And so that sounds kind of really esoteric, but here's a definition that most people think about what technology is. It's anything that was invented after you were born. It's all this new stuff, the stuff that's coming out of labs here. And if you're maybe a little bit more sophisticated, you might think of it as stuff that doesn't work yet. And, or maybe it's the stuff that's in your pockets, or maybe anything that has an on and off switch. And I think, of course, all those gadgets and all those things are the stuff that technology is, but it's actually something more than that. We can take 2 pictures, these 2 artifacts that are approximately the same size and shape, and one of them can be easily made by any of us here, not maybe as well, and that's the tool of the hammer, and that's prehistoric. Or the one on the right, the mouse or the iPhone or whatever you want to look at, that one not only could not any of us do, but even the group of us here could not do. In fact, even everybody in this building could not actually produce that. And that's because that device requires maybe 1,000 intermediate technologies to create it and maintain it and operate it. And each of those technologies might, in turn, depend on another 100 intermediate technologies. So what we have is the technology we have, like on the right, is actually representative of an ecology of technologies. It's a whole set of interrelated, interdependent, and codependent artifacts. And that entire ecology, or if you might want to think of it as a superorganism of technology, is actually what I'm most interested in it. And to distinguish that from the individual technologies or artifacts, I call that the technium. So the technium is this huge super hive, super ecology of all the technologies that we have as they are related to each other and codependent on each other. And what we know about systems that have that degree of complexity, there's two things. The one thing we know about those kinds of systems is that, first of all, they exhibit behaviors that are not present in any of the parts. Okay, so you can look forever in time into a bee or an ant, you'll never see the hive or the colony. So that behavior is not present in the individual components. And so the actual behavior of the technium is not present in any of the devices. It has a larger system-wide behavior. And secondly, those behaviors have inherent biases and tendencies. That's what we know about systems. Okay? And the more recursive circuits there are in this, the more tendencies there are. And so recursive circuit is the idea, an infinite loop, a recursive loop, where we see this in biology. We have genes. A lot of the genes in our chromosome are turning on other genes. They're not expressing protein, but they're turning on other genes. And some of those genes are turning on other genes, and some of those genes are turning on the first genes. And so you have this recursive loop. We have technologies that make technology A makes technology B makes C, and C is involved in the creation of A. So we have recursive loops within the technium, and whenever you have those, you have biases, tendencies. And so when I talk about what technology wants, what I'm talking about is what the technium is biased towards. So I don't mean want in terms of the way in which an intelligence or conscious being would want, but I mean want in the way that plants want light. They're leaning towards light. The tomato plant on your windowsill is leaning towards the light. It's not conscious, it's not intelligent. It has a bias in its system, an urge, a need to move towards light. And so we have plants that want light, and that is what the technium has, a certain wants. And the question I'm asking is, in general, what are the biases in the technium? And I begin, going back to plants, because my premise is that, in fact, the technium is an extension coming from us. It's not just from our minds, it's also from our biological past, from our evolutionary past, that the technium is actually extending and accelerating those same forces. And so I ask, what does evolution want? Now, I have to say right away is that there are some evolutionary biologists, among the most prominent was the late Stephen Jay Gould, who argued very, very forcefully that there are no trends in evolution at all, that is trendless, that there's no trajectories, there's no directions. And that is sort of the orthodoxy in evolutionary biology right now. But there are minority view, and there are other evolutionary biologists, and many of them young, who actually have more experience with computational and computer simulations, who actually make a different argument and have evidence to show that there are trends, directions in the long course of evolution. And the foremost of those is the ones that we all intuitively feel, which is that over 3.7 billion years of life, that life has gotten more complex. Now, the reason why that's maybe not an obvious trend is Stephen Jay Gould and others would say, well, if you're starting off simple, you have nowhere else to go but more complex. And so the fact that the leading edge is getting more complex is trivial. It's not important. The question is about the trailing edge. And so we can show, in fact, that when you have moved along some evolution and you are somewhat complex, is there any bias in which direction you go then? And we can show that there's a mild drift towards increasing complexity even at the trailing edge of evolution, say bacterium. So what does evolution want? Well, again, there is a trend. We have evidence that there's a trend in greater complexity over 3.7 billion years of life. That's one trend. But there's also trends towards more diversity, increasing numbers of different species. And again, that increasing diversity happens not just when you're starting off with simple, but even once you have some diversity, it rarely goes to less diverse. It generally, on average, goes to more diverse. And we can actually make a list of these things, including, increasing complexity, increasing diversity, increasing specialization. The first cells are general. There's one kind of cell that does everything. Over time, they evolve into specialities, and so we have 250 different cell types in our bodies. We can show that the number of cell types increases over time in evolutionary history. Increasing mutualism, codependency on other organisms as for your life, increasing ubiquity, increasing mindfulness, sentience. We see the mind and the kind of learning that a brain does in neurons, even happens in plants. We see it erupting throughout the kingdom of life. Many, many times independently, there's increasing learning. And evolvability, which is the ability to evolve. And so we forget the fact that the evolution process itself is not a singular fixed process, but itself it has evolved in complexity and it actually has made things easier to evolve over time. So it's actually, organisms can evolve faster, quicker, and more degrees of freedom now than they could 2 billion years ago. So there is actually the evolution of evolvability over time. And exotropy, which is increasing order, increasing self-organization, and increasing structure. So those are the kinds of things that we see. And the reason why that's important is because I think one of the kind of the most amazing discoveries in the last 50 years has been the realization that the essence of life was not water or some vital spirit or some mystical force in the world, but actually was information. We saw that with the discovery of the DNA code. We can understand that the essence of life was actually information processing. And of course, that's the essence of technology. And it wasn't too long ago that for the first time that we actually exported Darwinian evolution and moved it into a computational world. And for instance, we used it to evolve computer code. Microsoft Word has parts of its code that was evolved and not actually programmed by humans. So we moved evolution out of biology into computers, and at the same time we could take E. coli and assign numbers to its genetic sequences, and in parallel, kind of as a proof of concept, used it as a parallel processing machine to solve a traveling salesman program. So we use the parallel processing of E. coli genetics to solve a computer program. So we have evolution moving in computers, we have life and evolution moving from life and doing computation, showing that in some senses that there's equivalency between life and the technium, that the division that we normally think of them as a gulf is just not there, that in fact there is a continuum between the two. So that means that when we look at things like this, the 1800s, the diversity of smoke catchers is almost like a museum collection of different species of butterflies. And we see specialization, of course, happening in the technium in mechanical things. We make a computer or a camera, and then we might make the specialized underwater camera and an infrared camera and a high-speed camera, and then we can specialize that to make a specialized infrared camera or then a specialized infrared underwater camera. And so it kind of goes on and on. That specialization is happening. And we can even kind of map, in some cases, the genealogy of different inventions. And I think that the parallels are so steep that, in fact, we might even think of, these are the 6 kingdoms of life: plants, animals, fungi, and 3 kinds of bacteria. We might think of these 6 kingdoms of life as actually producing the 7th kingdom. And I think of the technium as basically the 7th kingdom of life because it shares so many of the attributes as a system, again, as a technium, not the individual artifacts, but as a system, it exhibits so many of the same self-organizing forces that life does, that I think of it as a 7th kingdom of life. So when I ask what does technology want, what are the biases and the long-term trends in technology, I get a very similar answer. And again, I want to go back to the idea that the want is not conscious but is real. That even unintelligent systems can have wants. So this is the Willow Garage PD2, I think, robot, which has been programmed to find its own energy to recharge itself. And so it will roam through its building looking for outlets, and then it takes this tail plug and it plugs in by itself. It plugs into the outlet until it's recharged, and then it takes off again. And I had the privilege of standing between it and the outlet, and it very definitely wanted energy. You could feel it, and it was going to find it somehow or other. And it was not conscious, it was not aware, it was not very intelligent, but it definitely wanted electricity. And so if we, again, ask what the technium wants, what it wants is the same thing. It wants to head towards, it's a general bias, to drift towards increasing complexity, increasing diversity, increasing specialization, increasing mutualism, ubiquity, settings, and evolvability, among other things. And so what does that mean? Well, here's one example of kind of a long-term trend in technology. If you take the power density, the energy density of systems that are in disequilibrium, like a galaxy, like a star, even planets with an atmosphere, life, you find that the amount of energy per second per gram, so ergs per second per gram, flowing through this system for the duration of the system, that the highest energy densities are actually increasing over astronomical time. And that, in fact, there's sort of more energy flowing through the cells of a sunflower than there is in the sun over its entire lifespan. And so the most energy dense entity that we know about in the world is actually the chip in your PC, in your computer. In fact, that's the problem for engineers, is that there's so much energy flowing through here and it's so dense that it's near explosion or meltdown. I mean, it's incredibly energy dense state, and yet we can actually say that where it's going to go is actually going to be even further in that direction. So these systems have their own agenda of some sort, and the question is, what is the agenda? And one of the agendas is, of course, to increase itself. I did a calculation that most of the power in the technium is using to serve the technium rather than us humans. When you're driving your car, 3/4 or more of the energy that you burn is to move the car, not you. You're kind of a minor passenger, literally, in this thing. And we have, your car then has a garage, which maybe need to be heated as well, even when you're not there. And so we have this thing in which the technium is increasing, at least servicing more of itself. There's more technology, and the more technology is, the more it needs. So that's one sense. And the other one, another sense of having an agenda would be Moore's Law. So a great question that I tried to answer was Moore's Law inevitable, or is Moore's Law inevitable? And Gordon Moore and Carver Mead could kind of develop this in the 60s. And this, of course, this unwavering line over decades of research, independent of the fact that people are constantly trying to accelerate it by putting billions into a fab or whatever, trying to go ahead of it. It still doesn't work. It's just very, very straight. They believed it was actually just a self-fulfilling prophecy. But of course, the problem was that this curve translated into, like, say, operations per second has been going on way before they were aware of it. And we see similar kinds of curves in bandwidth, storage, DNA sequencing, and all these curves are on the same kind of unwavering fixed slope, and they start long before people believe them, even when they deny that they're there. And so it's not just self-fulfilling prophecy. It is built into the mechanics of physics and chemistry, and the slope may be something that depends on the economy, but the fact that it's straight does not. And another example of an agenda is that most inventions throughout history and currently now are independently, simultaneously invented. There were 23 other people who invented light bulbs before Edison. When Alexander Graham Bell filed the patents for the telephone, 3 hours later, Asha Gray submitted for his idea, and both of them had been preceded by an Italian years before. And in every case, we even in places like, I looked at the studies of work during the Manhattan Project when there was 6 different groups working on things that were absolutely separated because of secrecy and wartime division. Even the 3 groups in the US were on a need-to-know basis and were not aware of the other's work. They kept very meticulous records, so we have absolute proof, kind of laboratory experiments of people inventing things completely independent and coming up with very similar things, and near at the same time. So whenever the precursor inventions are in need, or excuse me, are in place in this ecology, the next adjacent space is inevitable, and it will happen at that time, whether someone is, I mean, the person who actually receives it is just those who are putting themselves there. It's not really dependent on the lone genius, and this is the work of Stephen Johnson showing the same thing. Our idea of the lone genius is just incorrect. It comes from an ecology, an ecosystem of codependent inventions, and that the steps on these things are inevitable, and the progression is even inevitable. And I showed that in this book, looking at the prehistory inventions on different continents when they were separated and without any kind of communication between them. The sequence of inventions in prehistory on the different continents were very close to being the same in each case, showing that in a certain sense that the technologies that are coming are also going to be inevitable. And so, you know, the web was inevitable. Now, what was not inevitable is what kind of web we have. I think the expressions of it, it's sort of like the genre, the genius level is inevitable, but the speciation is not. So the light bulb, incandescent light bulb was inevitable, but the actual, you know, whether it was tungsten or not, what voltage, whether it was DC or AC, those were not inevitable. And the same thing with the web, the expression of it, whether it's centralized or decentralized, transparent, what the actual protocol is, those are not inevitable, and those differences actually make a huge difference to our experience of it. Okay, and I would say that as we look to the future, human cloning is inevitable. Now, in what arena, how is it done? That's not inevitable. We have some choices about that. Computer-driven cars, as you guys know, they're kind of inevitable, but not what the regulation is, not how we experience them, not the cultural infrastructure that we built around them. Those are things we do have choices about. And so humanity, I think, is something we've self-created. And whenever you have self-creation, that means that you, which we are, we've created ourselves. We are both the created and the creator. So there's kind of a tension that we have about technology from the very beginning. We are self-created in the sense that very early on, we started doing things like creating an external stomach to cook our food, to cook food that we could not digest ourselves. And that external stomach actually changed our nutrition sufficiently that it actually altered over time the size of our teeth, the position of our jaw, the enzymes in our body. And so we're now dependent on cooking. But it actually has changed our genetics. So we've modified ourselves. Through our brain, through our technology, we have modified ourselves. We have remade or made or created ourselves. And a lot of what we identify with humanity is, in fact, from our laws to our sense of justice to maybe even our language, are things that we have made with our minds. And we're self-created. And as again, self-created, that means that we are both the creator and the created. We are both masters and the servant. That happens when you are self-created. That invention of language about 50,000 years ago changed the population dynamics. We were only 8 to 10,000 in total, maybe in the world. And as soon as we had language, we had a tool that gave us access to our own minds. I think the Neanderthals were probably pretty smart, but didn't have any kind of control over that because they didn't have language. Language is not just for communicating with others, but communicating with ourselves. And so with language, we had tools, we had technology, we could deliberately make things rather than just kind of encounter them. And we spread very fast. In fact, we spread across every watershed in the planet at the scale of 1 mile per year. That's how fast the expansion of humanity was around the globe. 1 mile per year, we settled the entire globe in a couple thousand years. And so with this technology alone, for a long time, we actually modified the entire planet. The early hunter-gatherers eliminated 250 species of megafauna to extinction, long before. I mean, these were the kind of the people living in harmony. Supposedly, these people completely altered the whole mix of, because once you eradicate the megafauna, it changes the whole speciation of the ecology. And even by the time we got to agriculture, 10,000 years ago or so, agriculture started to change the climate. So climate change actually preceded the industrial age. So really, from the very beginning of our tools, technology has become a planetary force. And in fact, I would say that it's now the most powerful force in the world. Most of the things in our lives, we can kind of draw back its origin to something that we invented. And most of the change in the future, of course, will all come from things that we invented. And what I'm saying, of course, is that the greatest invention that we made is our own humanity. And, of course, we're not done yet, and that's the whole point of this. So technology is selfish in the sense that it has its own agenda. We are the created. So it's selfish in that sense. But also, at the same time, it serves us. We are the creators. And that tension between being created and the creator, being the master and the slave to technology, is never going to leave us. And it's the cause of all our kind of constant tension. And in 1,000 years from now, with new technology, we'll still be wrestling with the fact that we are both the created and the creator, that technology is both selfish and serves us at the same time. And that duality, that tension is never going to leave. And of course, most people would embrace technology, I think, but there's concern about, is there any limit to it? Is this going to take over, become the techno planet, and wipe out the biology? And what's interesting, if you take my assertion that in fact the technium is an extension of the evolutionary force, that it's a continuation and acceleration of evolution in life, that means that actually so far what we know is that there's no technology that we discovered yet that could not be made greener, more compatible with life. And so while there's much about the technium that is not compatible with life, that's grimy and dirty and inhumane at scale, there's nothing inherent in the technium about that. That's not inherent. So we can make more green stuff that is compatible with life and living. In fact, when you make these chips for the computers, they require a purity of water that actually exceeds what we're drinking. And so in a certain sense, you can say, well, yeah, even technology wants clean water. So there is a sense in which that's necessary for technology, just like for us. And so I think the technium inherently is not incompatible with life, but is compatible with life. And I like the way to think of it. If we have a technology that is not green, maybe it's actually very harmful to the environment, I think of that as like a bad idea. And so what's the proper response to a bad idea? Well, if someone here had a bad idea, we're not going to say to them, think less. We're going to say, come up with a better idea. And I think that's the response to a bad idea, is a better idea. So when you have a bad technology, maybe you're spraying DDT across cotton crops on a plantation scale, in millions of pounds a year, and that's an environmental disaster. So the response to bad technology is not less technology. It's better technology. So we can reform. We take the same technology, the same chemical DDT, and if we apply it around households, it is the most effective eliminator of malaria, saving tens of millions of lives a year. And so we can relocate a technology. And so most of the problems in the world today are technogenic. They're caused by previous technologies. Every new technology will make new problems. In the future, most of the problems of the world in the future are going to come from technologies that were invented today or in the future. So they're all going to be technogenic as well. And so, so there's a tendency, because so many problems are technogenic, to say is we need less technology. But in fact, we just need better technology. Understanding, of course, that the better technology is going to generate its own problems in the future. So I think our kind of a jobs as humans is to kind of like move the DDT into a better job, to find the best jobs for our mind children. And you know, they're sort of, just like we have our children, we kind of want to guide them in the right thing, make sure they have the right friends, put them in the right context, in the right environment, and really try to look for what it is that they want. And I think there's no bad children, there's really no bad technologies, there's just technologies looking for the right place. And I think that even that's true about lots of technologies that are weaponized. I mean, it's not inconceivable to me that there might be some place in space where you might want to have nuclear bombs. They are a terrible thing for killing humans, but they might be useful for other things. And as long as we're on Earth, we probably don't want them. So what technology wants? It wants increasing diversity, increasing options, choices, opportunities, possibilities. That's what technology gives us. Okay, so I acknowledge that technology, and new technology, will often produce as many problems as solutions. Okay, so people will say, well, that means that technology is just neutral. That's sort of the orthodox view of a lot of technologists. It's a neutral tool. You can use it for good, use it for bad. It's a hammer. You can kill somebody or build a house. Okay, and in a certain sense, that is true. But there's one difference, is that when that hammer was invented, it presented you and the world and us with a new choice we did not have before. And I say that that new choice itself is a good. Just the new choice itself is a good that tips the balance slightly, very, very slightly, in the favor of good overall. Okay? So every new technology itself, while it can create new problems, the fact that it is increasing our choices and our possibilities is itself in the good. And it turns out that you don't need it to be a whole lot better. It can be a little bit better. So if through technology we can create 1% more than we destroy every year, compounded over years and centuries, that 1% difference is civilization. That's progress. Okay? So we don't need to have that much. Maybe it's only a tenth of a percent. So 49.5% of the world could be crap and terrible and horrible. But if 51 or even 50.5% is great and good and increases our choices, that is progress in my eyes. That's how we get progress. So that's why it's not just neutral. I think there is a moral dimension to technology. It's not neutral. And you know, we are increasing our options and possibilities. I did, with my daughter, I did a count of the number of objects in our house. There was around 10,000 different objects. I looked at the inventory of the King Henry VIII of England. When he died, they did an inventory of everything in his household, which doubled as the Bank of England. Okay, and there was 18,000 objects. So basically, the wealth of England was 18,000 objects. And so, you know, in some sense, we're kind of approaching the wealth of kings of old in our normal everyday life. But actually, it's even more interesting because the wealth of King Henry, all his wealth in total, could not have purchased a tube of antibiotics ointment that could have saved his life or someone he loved. I think Rothschild, the wealthy, one of the first multimillionaires in America, died of an abscess that could have been cured with $2 worth of antibiotics, but his wealth could not have bought that. And this guy, this rickshawwala in India, could have so many things that King Henry and all his wealth could not buy, which was, King Henry could not have a flush toilet, and his wealth could not buy refrigeration. He could not buy a comfortable ride for 100 miles. All these things, and this guy could afford these. And so in that sense, he and us are far wealthier than King Henry ever was. That's what progress is. That's what this stuff brings us. And it gives us not just progress, but choices, possibilities, opportunities, longevity, increased education, all these things which are pointing up over time. And I want, it's what I want to emphasize is that when we spend our time making new things, it's not just, we're kind of sometimes dismayed because we make things that people forget very easily or they throw away. We seem like we're involved in just selling more stuff, and it's consumerism. And so there's a sense in which we're kind of just creating lots of stuff. And we say, well, why are we doing it? What's the value? And I'm saying what it is there's a larger thing, which is that we are actually increasing the choices and possibilities and options of the world. And the reason why that's good is because we're actually partaking in something that is larger than us. That this sort of force of self-organization, of increasing diversity, began at the Big Bang. And it's been running through the rest of the world, the universe is running down, and entropy is going down. But there are places where we can accelerate the creation of entropy and increase local order, exotropy. And that's one of those neighborhoods is this Earth and this life on Earth, which is increasing its order by accelerating the creation of entropy. And that self-organization is kind of running through the galaxies, which maintain their order, or stars, which are machines for building up heavier atoms from lighter atoms, and they maintain themselves for billions of years. And that self-organization is running through life and into the technium. And so we can align ourselves with something much bigger than ourselves. It goes back to the beginning, and is going to run from the beginning of the universe and actually beyond us, go beyond us, even as humanity is in the middle of something. We're not the end of anything. And so that long arc is actually increasing choices and possibilities. And the reason why that is important is because I think that we often need these new tools for each of us to express our inherent special mix of talents and abilities. We all have different faces because of the different mix of genes and things we have. We all have different mix of talents and abilities, and the technology is often required for us to find and express that. So I like to think of Jimi Hendrix and the fact that the invention of the amplifier, he played the amplifier, not the guitar. So the amplifier actually allowed his genius to be shared in the world. And then I think about, well, what a hole in us we would have if he had been born before the amplifier had been invented. Or if Mozart had been born before the technology of the piano had been invented. Or maybe Van Gogh before oil paints, or Hitchcock before the invention of the technologies of cinema. What a loss that would be to us. And so, in a certain sense, I think there are today, somewhere in the world, a boy or girl, a genius of some sort, who is waiting for us to invent those tools and technologies that would allow their genius to be shared. And so I think we actually have a moral obligation to create those things, those possibilities, to maximize those possibilities for everybody in the world, so they would have some chance to really find and share their genius with us. And because we actually have been benefited by others in the past who have been making new things for us. And so we're here to make more technology, to increase those possibilities. And that is part of this long cosmic evolution, this long thread of self-organization that's moving through us and beyond us. So I thank you for your time, and if you want to look at the book, Amazon and others have it. That's the general thesis, and I think we have time for a few questions. I'd be happy to answer them. So thank you. So, total agreement. I love it.
Hi. two questions of
Yeah.
clarification, I think. In the middle of your talk, you were talking about things being inevitable.
Yeah.
Do you mean literal, like logically inevitable, or just overwhelmingly probable?
Tell me the distinction between those two.
Logically, the logically thing that I was trying to get at is that there is no way it could have been prevented. It would just follow as a course of almost mathematics, versus probabilistically inevitable means, yeah, sooner or later, it's likely enough that sooner or later it will happen.
I think the universe is basically probabilistic. I think everything about the universe is probabilistic. So I would side with probabilistic rather than logically.
Okay, so in that sense, you know, arguably it could have happened that we had bombed each other back into the Stone Age in the 50s, and there were no iPods. There would have been no iPods for some period of time. That's still consistent with what you mean inevitable, is that, yeah.
Sure. So
Okay.
I mean inevitable in the sense that there's inevitable progress in human development, meaning that you start off as a fertilized egg, you grow into a fetus, you know, embryo, fetus, toddler stuff. Now, and so it's inevitable that a human become a teenager. Now, obviously, there's lots of humans who die before they ever become a teenager. So, is it inevitable you become a teenager? Well, if you die, then you say logically you can't. So, yes, there is. So probabilistically, it's inevitable.
The other question I was going to ask to clarify is that I think you used the word technology in a couple of different senses, at least over the course of the talk.
Right.
The main thrust of it is when you seem to be talking about it as if it's something that has some kind of existence in itself in the way that society does. Is that what you were trying to get at?
So I use the word, in the book I'm a little bit more consistent, I use the word technium, but that's a word I've coined, so I was trying to ease people into the idea. But the technium, as I said in the very beginning, is the system, the interdependent system of things. It's not the collection of the individual artifacts. It is a system, an ecosystem, you might think of it, a super system of all the things that our minds create together.
Right. Would you also use the phrase that technology was a force?
Yes.
So you view it as a system and a force?
Right. I think that the force of it is actually, it's the exotropic force. So it's a force in a way that you would say a big truck coming down the road is going to hit me. You know, that's a force. It's a force created by an artifact. So the force in that sense is not. You're actually talking about the energy of it. And in my case, when I talk about the force of technology, I'm talking about the exotropic force that is within technology.
Thanks for coming to speak here today. I think a lot of what you say really rings deeply true to me, and then I'm sort of struggling with what the implications are to take back down, because I feel like I've sort of had a moment of enlightenment reading what you've been saying, but the fact that sort of on the one hand, a lot of these trends are inevitable, and I think if you work at Google, you realize, like, on the one hand, we're trying really hard to move ahead, and on the other hand, the wolf's at our back the whole time, right? So I think it's pretty clear. But that in any kind of short, meaningful period of time in terms of product cycles or competition or what people are working on, it's totally not inevitable. In fact, totally contingent on what we choose to work on and what other people choose to work on. And so sort of, and I was actually fascinated to hear, I forget if it's in your book or in other writings, that you actually have a lot of very specific ideas about what technology you do and don't use and keep near your house and keep near your family. So even though overall you're very bullish about this, you think you can actually intervene in lots of meaningful ways. And that maybe the longer term trends, are they appropriate for government policy and things like that, or just, sort of, in other words, how do you bring it back down for you and for others?
Sure. So one thing I would say about inevitabilities is that there's a certain sense in which, if you use the word inevitable, they're kind of fighting words. It kind of brings up lots of reactions, and I think rather than kind of flee from inevitabilities, I think I would use them as sort of like a helpful signal, the fact that we can prepare for them. We can prepare our education, we can prepare our businesses, our models to anticipate and maximize their good when they come and minimize the harm. And so If you knew, I mean, if you went back to, say, Moore's Law, and in 1960 you kind of believed Moore's Law and realized that this was inevitable, think of all the things you could do in the following 50 years if you really knew that every year computers would get twice as fast and half as cheap. You wouldn't have to know anything about IBM or Apple or Google to make a lot of money, first of all, just on that one simple acceptance. But there's also lots of things you could do for culture and education, really understanding that it was inevitable. So the question you asked, though, about, how do you go back and how do we make it into our own lives? Yes, I mean, one of the things that's interesting is that while I'm preaching in a certain sense that we want to actually increase the amount of technology in the world, I myself am actually trying to minimize it in my own life. Okay, and the reason why is that what it turns out to be is to kind of find that place, that those tools that are best for your genius. It's not all technology. It's going to be a very select amount of technology, and those other technologies are actually distractions. And so in a certain sense, what you're actually trying to do is find that small set of technologies that are appropriate for you and ignoring the rest. And so that's what the Amish do in a certain sense. And then there's a chapter in the book about the Amish, which I hung out, and I was in great admiration of them. They're very, very selective. They're not Luddites. They're just very selective in a curious way. I mean, they have horse and buggy and bonnets and stuff, but they use disposable diapers. They're really into chemical fertilizers. They use genetically modified crops. Okay, so they're very, very selective. But the reason why I'm not Amish is because they only do one half of it. They're trying to minimize the technology in their lives, but they're not trying to maximize the technology for others. They're actually dependent on us to do that. I think we have to do both. I am interested in minimizing my selection while I maximize the larger pool for others to choose from. Okay, so I think that tension again is also going on, and I think there's more technology that's being invented, and there's more of it every year than we could possibly ever ourselves adopt. So we have to have some criteria. We can't just randomly try stuff. We have to begin to cultivate some kind of criteria, narrow it down while we encourage the increasing choices for others. Yes.
So earlier in your talk, I was really struck by something you said about our expectations about technology, the role and the purpose. For me, my belief is that someday the universe is going to kill us all, right? I mean, a supernova or a comet strike or eco-catastrophe or whatever.
Yeah.
And nothing lasts forever. And I see technology as our best bet for postponing that day as long as possible.
Okay.
Would you say that's the way to bet?
Well, I'm going to bet on technology, yes. I think what I'm trying to suggest is that the difference, I think that we becoming more technological, that we are part of, the Technium is not something that's out there, it's something we're part of. And so I don't see much distinction as we go along between us and technology. We are already cyborgs. We're already there. And it's not just, I think we may have multiple species. That's the real question. There are going to be people who say, under no circumstances am I or my children ever going to manipulate our genes. And there are other people who say, yeah, sign me up tomorrow. And we may become multiple species. And so I think the very definition of what humans is we're in the process of redefining it. Every time there's a new innovation in robotics or AI, we have to redefine who we are. We thought we could do this, and what humans are. And it's not just what we are. I think the huge problem, the huge challenge we have is that we kind of define who we can be. And we don't even have any kind of process for that, for collectively deciding what humans want to be. So I think we're at the beginning of this in terms of even defining who we are. Yeah.
So I guess one of the underlying principles here is that culture and technology are evolutionary systems, and therefore share a lot of interesting attributes with the evolutionary systems that created life.
Right.
I think this is a very interesting area of study, but something that's hard for a lot of people to swallow, just because I think our general understanding of evolved systems is still very weak.
Right. We have the problem with evolution is we have a case of one, which is really hard to generalize about.
Exactly. Now we're getting more of these cases.
Right.
But what can we do to sort of enhance this understanding or further the study of evolutionary processes in general and what they could mean and how we could use them?
Actually, I had my mind changed about evolutionary systems when I realized we could actually make another form in computers. We could do evolutionary studies, and we could let Darwinian evolution run in computers. And so I think simulations and other things where we actually make more powerful systems and we let them go and we let them invent things, I think will teach us more about evolution than studying more stuff in the field would be. So that's what I would say. I think the power of simulations as a tool of science has just begun. And again, referring to my earlier talk on the evolution of the scientific method, I think that's one of the big things that we're looking at in the future in the scientific method is the role that simulations will play. So, yeah.
Great talk. Thanks for coming. Lots of interesting ideas that provoke
yes.
tons of evening conversation.
Then I'm useful. That's the whole purpose of the book.
So I have a question, though, about doesn't this actually reduce to something else, and this is kind of a half measure?
Okay.
So technology, you talk about simulation.
Yeah.
And indeed, we can simulate evolutionary systems, but as soon as we pull the plug or the power supply no longer has coal,
right.
It's done. It will not
right.
self-perpetuate.
Right.
And so at some point it may be inevitable that it will
right.
self-perpetuate, but I kind of doubt it at this point.
Right now we are the sexual organs of technology. We're
right.
necessary for it to reproduce.
So when you say what technology wants, that personification makes me think, actually we are the creators of technology, so it's what we want. And even the supporting technologies that are necessary to support other technologies right. are just back-chained complexities and dependencies, but it's still ultimately what we want. And if we're driven by the selfish gene, which is driven by some even more primitive,
right.
like prokaryotic bacterial
right,
messaging
right.
or whatever, then ultimately doesn't this reduce to what does information want?
Yeah.
And so does this bias any value framing it this way?
No, I mean, I think it's a really good question. If you kind of trace back and say, how did life self-organize? Where did that want come from? It's a huge mystery, and that's not even the beginning of the mysteries. If you go back and say, well, it's all information, we have no idea what information is. You ask any cosmologist, any astronomer, is information being conserved in the universe or not? And they say, don't know. What's the definition of complexity? Don't know. And so the mysteries in this are profound. And I'm not suggesting that this isn't going to solve any mystery. I'm only suggesting that, in fact, we can place technology in this frame of reference to these other mysteries. Maybe that's the best way to say it.
Okay. Is there a key takeaway piece of utility you get from that?
Yes, and I think that is that the distinction between life and between technology and life is very thin. That basically think of the technium as an extension and acceleration of evolution, and that we have much better understanding where technology is headed if we understand that it's actually closer to an evolutionary force than it is something that we're just inventing with our minds.
Thanks.
Yeah.
So to me, it's kind of surprising and also encouraging that you take such an optimistic view of sort of what technology wants
right.
with respect to creating more choices, possibilities, making people's lives better.
Right.
Because technology is kind of this extension of evolution, and it is the sort of byproduct of this process that sort of we're just kind of one part of.
Right.
Our subjective experience and our feeling of good versus bad is sort of independent of this in some sense, except in that it causes at the system level these things to continue happening. To me, it seems like, if you look at, for instance, the evolution of multicellular life, right? This was a tremendous win for life in general, but for single cells, for
right.
instance, this may have actually been kind of terrible. Like now you've got things that need to
sure.
spend their entire existence as a stomach cell, say.
Right. We had the same kind of thing with the invention of oxygen, or not the invention, but the creation of oxygen, which killed off all the previous, a lot of the previous life was killed by oxygen, which of course was necessary for the other life.
Yeah,
so,
exactly. So, you kind of have this thing where, actually the individual actors that give rise to this next level of evolution tend to not always get the best deal out of it.
Right, right. So one of the things actually I think that evolution is moving towards, and this may speak to it. Well, I didn't put it on this list because it wasn't. This list was not complete. Is actually it actually is making increasing choice and freedom of choices and degrees of freedom. And so as individuals, we actually have right now compared to, say, 10,000 years ago, we have far more free choice than they had 10,000 years ago. Because we actually have more free choice, both, I mean, in terms of our minds, because we're more aware than, say, someone who had no language at all. And so I think that even as individuals, we do have increasing free choice. So it's that, and in the fact that we realize that our choices are part of something larger. And I think that dichotomy between being masters and servants will never leave us. It's not going to be nature, nurture. You can't unravel the two. You know, master, servant, you can't unravel the two.
Thanks.
Yep.
So I'm wondering how you take, say, security technologies into account in this. I think there's a situation where, let's say in a video game, for example, if you just give everybody more power, and they become, so everybody's a superhero, then they can all essentially attack each other, and it becomes not very interesting anymore because everybody's just ridiculously overpowered.
Right.
And it seems like by giving people more choices, you're giving more power to interfere with other people's choices.
Well, there's something, you know, Barry Schwartz has talked about the tyranny of choice, and this idea that if you give people too many choices, they become paralyzed. And so here's the solution. Again, this is my technocentric view. I think the solution to overwhelming number of choices is more technology that helps us make those choices. And that's what Amazon recommendation is. That's what those collaborative filtering is. And so the solution to like more choices is another choice to use choice filtering, choice aiding technology. And I think the same thing with what you're suggesting is, you know, if there's all these choices, well, the solution is going to be, sorry to say it, more technology.
Well, I guess
better technology.
The question is when people have different ideas about what they want to do and they can interfere with each other, then having more choices isn't this benign thing. It can negatively affect other people. And one of the things that you want to see for creativity is as like...
Right, but the only other solution, I mean, if it isn't a better choice or better technology for choices, is less choices, and I just don't think that, that's what I'm saying. That goes against the entire arc of evolution. So I would not bet on that. I would always bet on better technology for making choices than less choices.
Fair enough.
Okay. I have the last question, and then I guess you're just almost 7 minutes after, or I guess it's time to move. Yeah.
So you said humanity was the sexual organs of technology?
Yeah, well, it's okay.
Do you think
that's not my line, by the way. I think that's McLuhan.
Will that continue, or do you think that'll change eventually?
Well, that's, you know, yeah. So right now I'm arguing that we are giving the technium a little bit of autonomy. So autonomy is not binary. It's not like you're there or don't there. You have little bits of it, including us. We're not totally autonomous. So I think we're going to increase the amount of autonomy. Can the technium ever be autonomous? Well, in the sense that we're part of it, not really. I mean, we will always be part of the technium. So it's not as if we're going to be separate from it, or ever separate from it. So can it, you know, I mean, yes, I think there's going to be certainly increasing amount of technology, of autonomy in the technium. Will it need us to not reproduce? I don't know. I can imagine different scenarios. Let me put it that way. I think there's multiple scenarios. Yeah, it's inevitable that it would in some cases, but there may be other cases, other things that we do where it isn't. So, in the sense that you want to have, or wants to have multiple possibilities, I think. What I'm saying is I don't think that it remains one species. I think we see divergence. And so there are some possibilities where it will be completely without us, and there's others where we're still essential. Those, most of the time, the future is not a single, I'm not talking about a ladder where we're climbing up a single race. These trajectories are like explosions. They're not like going along a series on a ladder. So again, I thanks for sticking around. I really appreciate the questions, and I hope you enjoy the book. Thanks for having me here.